three schematics and then how to wire those schematics, or how I wire those schematics on a breadboard. My first schematic has two LEDs. The first LED is controlled by a button going into a parallel setup, and the second LED is controlled by a button going into a series setup. It's important to note that in this case, even though they're in the same schematic, they are not connected to each other. They just share the same 5-volt and ground sources. So we have 5 volts coming from the board going into the first LED circuit, and then 5 volts going into the second LED circuit, and then both are connected to ground. They're not connected to each other. They just share the same 5-volt and ground sources. The second schematic is a voltage divider schematic where I have a photoresistor and a 10 kilo ohm resistor, and the voltage divider is going into an LED where the LED will change brightness based on the light level that the photoresistor sees. And the third schematic is an RGB. In this case, it goes red, blue, green, but each of those LEDs is controlled by a 10 kilo ohm potentiometer. So before I even start wiring a schematic, I look at the flow of electricity. So in this schematic, I look at how the electricity flows. So it goes from the board, so 5 volts flows through this wire. It goes, let's look at the first LED first. So the 5 volts flows through the button, through the parallel resistor setup, through the LED, and then back to ground. For the second resistor setup, or the second LED setup, the 5 volts flows through the button, through the series resistors, through the LED, and back to ground. So again, I'm looking at how that power is flowing. So as long as you connect it so the power flows in that same fashion on your breadboard, it should work. So let's look at this kind of a scarier looking schematic. 5 volts is again, so 5 volts is going through that first potentiometer, back to ground. 5 volts going through the second potentiometer, back to ground. 5 volts going through the third potentiometer, going back to ground. But how is the actual power getting to the LED? It's coming out of the second pin of that potentiometer. So remember that potentiometers have 3 pins. The first pin is 5 volts, the third pin is ground, and that middle pin is the one where the voltage out comes from. So that middle pin here is the one that's going into the LEDs. So depending on how you have your potentiometer set, that's controlling the voltage that's going into the LEDs. And then the power goes through the LED and then back to ground. So in all three of these schematics, the power flows from the board through your system and then back to ground. So let's look at how to wire up the first schematic here. So in the schematic, there's two circuits. There's the LED that has the parallel resistors and the LED that has the series resistors. It is important to note that even though these two circuits are in the same schematic, they're not actually connected to each other. They just share the same 5-volt and ground sources. So I have 5 volts coming from the Arduino out to the breadboard going into both circuits. I have ground coming from the Arduino out to the breadboard, and both circuits go into ground, meaning they're complete circuits. So the first thing I do when I'm breadboarding is I connect the 5 volts from the Arduino out to the breadboard. So I'm going to do that over here like so, make it straight just to make it look good. I'm going to change this wire to red to show ground, or show 5 volts, I'm sorry. Go to ground, connect that from your board out to the breadboard, make it straight again just to look good. I'm going to make that wire black to show ground. The way I do breadboarding is I use what are called the bus rails. So these vertical rails where it has that positive and that minus, those are called bus rails. So anywhere along this rail now, since I have the 5 volts connected to it, anywhere along that bus rail now has 5 volts. Same for the ground rail. So where I have ground connected to it, anywhere along this rail is now ground. So these rails, the bus rails, are connected vertically while everything out in the breadboard is connected horizontally. So the rows are connected. So over here the bus rails are connected vertically, the breadboard itself is connected horizontally in the rows. So to start wiring up the schematic, the first thing I do is get all the parts I need. So there's 2 buttons, there's 1, 2, 3, 4, 5 resistors. They're all 330 ohm resistors in this case, and there's 2 LEDs. So I've got all my parts over here, my 2 buttons, my 5 resistors, and my 2 LEDs. I've got an orange and a blue LED. Does not matter about the color. So I'm going to take my button, my first button, put it on the breadboard. Usually we do it across the gap. So I'm going to put that one there. I'm going to put the other one down at the bottom just to give myself enough room to do both circuits on the same board. I'm going to go ahead and connect 5 volts to the top button. Make that red again. I'm going to do the same thing on the bottom button. Just connect 5 volts to it. And see how I'm connecting from the positive bus rail out to the button. That means I have 5 volts going into the button right now. So I'm going to do the parallel circuit first, so the 3 resistors going into the LED. So take my first resistor and put it into the same row as this bottom leg of the button. We usually do a caddy corner just because if you go from this leg to this leg, they are electrically connected whether the button is pushed or not. So if I had something connected here, it would have 5 volts whether the button was pushed or not. So if I put it down here on this caddy corner leg, it won't have 5 volts until I push the button. So since these resistors, or since this circuit is a parallel setup, these resistors need to be in the same row. So the first leg of the resistors needs to be in the same row, and the second leg of the resistors needs to be in the same row. That's so when I push the button, the 5 volts flows through the button into each of the resistors at the same time, so it can flow through it in a parallel fashion, and then come out into the same row where the second legs are. The next step for that circuit is just grab the LED. I'm going to use my orange one. The way Tinkercad has it set up is this bent leg is the positive leg and the straight leg is the ground leg. So I'm going to put this down here. I'm going to connect a wire from the same row as my 3 resistors, so right here in the same row, and go down to the same row as the bent leg of my resistor, or my LED. I'm going to make that orange just because it's the same color as the LED. So this circuit is not complete yet because it's not connected back to ground. So my last step for this circuit is to connect the straight leg, so the same row as this straight leg here, over to my ground rail on my board. I'm going to make that black again to show that that is the ground wire. So if I run my board and push the button, the LED lights up, meaning the circuit is complete. So now to do the series circuit down below. So my button's already wired, so I'm going to grab my first resistor. Again, it needs to be in the caddy corner leg, so I'm going to put the first row or first leg of the resistor into the same row as the caddy corner leg. Since this circuit is a series circuit, the power needs to flow through the button first, through this first resistor, and then through the second one in a row. So I need to put the first leg of my second resistor into the same row as the second leg of my first resistor. So this leg is now in this, they are now in the same row, meaning they're connected. Now I need to get my LED. Again, that bent leg is the positive one, so I'm going to put that positive, or since that positive leg, into the same row as the second leg of my second resistor. And again, I need to connect that back to ground, so drag that ground wire from the same row as my ground leg into my ground rail on my board. So now when I run the boards, if I push the button for the orange one, it lights up. If I push the button for the blue one, it lights up. So both circuits are now electrically complete. So let's look at the second schematic I've got. So this is a schematic for a voltage divider using a photoresistor and a 10 kilo ohm resistor with the V out coming from the voltage divider going into an LED. So the LED is going to change brightness based on the photoresistor and the light level that it sees. So let's go over to the breadboard. I've already got my 5 volts in my ground connected to the breadboard like I showed previously. I've got my components up here. I've got my photoresistor, a 10 kilo ohm resistor, an LED, and then a 330 ohm resistor. So I'm going to take my photoresistor, put it out on the breadboard. I'm going to connect 5 volts from my positive rail to the first leg of that photoresistor. I'm going to make it red again to show that has 5 volts. I'm going to take my 10 kilo ohm resistor, connect that first leg into the same row as the second leg of the photoresistor. So the power goes through the resistor first, through the photoresistor first, and then through the 10K resistor second. I'm going to go ahead and connect that back to ground just to get that part done. And then I have to do my voltage out wire, so the voltage that is coming from the voltage divider and going into the LED. So that wire needs to be connected on the same row as the second leg of the photoresistor and the first leg of the 10K resistor. So right here, so where these two legs are, that wire for V out needs to be connected. So I'm going to connect it right there, drag it down here, make it orange just because I'm going to use an orange LED. I'll take my resistor, connect it in the same row as that of the wire I just connected. So again, same row. And then I'm going to bring my LED down. Again, the angled leg is the positive leg. The straight leg is the negative leg. I'm going to put that angled leg into the same row as the second leg of my 330 ohm resistor. And then finally connect the ground leg of the LED back to ground. So I'm going to make this wire black. I've now got this connected to ground and connected to the same row as that of the ground leg of the LED. So when I run this, when I increase the light level of the photoresistor, the voltage out goes up. So this slider works as up here there's no light, down here is full light. So as the light level increases, the voltage increases. So that is how it works for this setup of the voltage divider. So again, no light, the LED is off. As the light increases, the voltage out increases, and that LED starts to get brighter. So now on to the third and final schematic that I'm going to go over in this video. So I've got this schematic which shows 3 potentiometers controlling an RGB. So each potentiometer controls one of the LEDs of the RGB. In the case of Tinkercad, it goes red, blue, green, and then ground. So I've got my 5 volts coming in, going into each of the potentiometers. I've got the voltage out from the potentiometer going into each of the LEDs. So remember that the potentiometers have 3 pins. The first pin is 5 volts, that middle pin is the voltage out, and then the third pin is ground. So I've got 5 volts going into the potentiometers. The second pin is going into each of the LEDs. So the first potentiometer goes to red, second potentiometer goes to blue, and then third potentiometer goes to green. So let's look at how to wire that on the actual breadboard. So again, I always get all my stuff out first. I've got my 5 volt and ground connected to the board again. So let's go ahead and do the first potentiometer. I'm going to put that one here, put the second potentiometer here, and then the third potentiometer here. So the first thing to do is connect the potentiometers to 5 volts. So I'm going to make my wires red. I'm going to go from 5 volts to that first pin of the potentiometer, so the first pin of each of those potentiometers. The next thing to do, go ahead and connect those to ground. So I'm going to go ahead and connect the bottom pins to ground. So make sure that I'm connecting that black wire into the same row as the bottom leg, and the red wire, the 5 volts, is in the same row as that, the top leg. So now all my potentiometers are connected to 5 volts and ground, and I need to run the wires for actually controlling the RGB. So I'm going to put the RGB down here on the bottom of the board. It goes red, the ground leg, blue, and green in this case. So I'm going to take my resistors. I'm going to do my red leg first, so put the leg of the resistor into the same leg or same row as that leg of the red resistor. Take my second resistor, put that down into the same row as the same leg of the blue resistor or blue LED, and then the third resistor, put that down into the same row as the leg of the green LED. So now I need to connect these resistors to the potentiometers so they actually control the RGB. So I'm going to go from this leg, the middle pin of the first potentiometer, have that go down to red. I'm going to leave it as a red wire to show that it controls the red LED. The second one is going to be the blue LED. So I'm going to go from the same row as the middle pin of the second potentiometer down to the same row as that of the resistor going into blue. And I did make a mistake just now with this red wire. I connected it into its own row, and this resistor is in its own row. So these two are not connected right now. So I need to move this red wire down into the same row as that of this resistor. So again, the way I had it, they were very close, but they were not connected. So now that this red wire is in the same row as the leg of this resistor, they're now connected. The blue wire is now in the same row of this resistor, so they're now connected. And then I need to take a wire from the middle leg of that third potentiometer, put it into the same row as the third resistor, make that green to show that it's controlling the green LED. So now it's almost complete. The only thing that I need to do now is connect the ground of the RGB back to ground on the board so the circuit is actually complete. So I'm going to connect in this row right here that is connected to the ground leg. So this row has the ground leg in it. I'm going to connect that back to the breadboard, make it black to show ground, and then when I run the simulation, turn the breadboard on, if I turn all the potentiometers to 0, So now they're all at 0. If I turn the green one all the way up, green turns all the way on. If I turn the blue one all the way up, blue turns all the way on. Red all the way up, red turns on. I can make it purple. I can make it white by turning them all on. And then just play around with that. Now, right now, I've just got this connected to 5 volts, so they're getting straight 5 volt power. If we wanted to connect this to our digital pins to have a code run this, we could just take our, let me turn this simulation off. We could just move the wires that have the straight 5 volts, we could just move those to the digital pins. So if I wanted to have digital pin 11 control my red LED, digital pin 10 control the power going into the potentiometer for the blue LED, and then move that to digital pin 9. So that's how I would do it if I wanted to have the digital pins controlling the power flowing through the circuit. But for this case, I'm just going to leave them as getting straight 5 volts from the actual board itself. So that's a kind of a quick example of how to do breadboarding based on 3 schematics. Hopefully this will help kind of answer some questions about schematics and kind of just show that the best way to learn schematics is by practice. So just practice them, look at how to wire them from the schematic to the breadboard, and as you do that over and over, you'll get better at reading the schematics.